the infinite geometric series. Let's start off with an example. 1/2 multiplied by 1/2 would give me 1/4. Multiplied by 1/2 would give me 1/8. Multiplied by 1/2 would give me 1/16. Dot dot dot. Let's see this on a number line. 0, 1. Okay, so let's do 1/2, which would be there, and then 1/4. So here's 1/2, and now let's add 1/4 to it. No, the quarter is right there, and then let's add an 1/8 to it, which is this guy, and then let's add a 1/16 to it, which will be this guy, and then we'll keep on going. We'll keep on having and adding it, and I think we can see that if we do this forever, we will approach the sum of all these numbers will approach 1. And I'm going to prove that to you. So let's just write down the sum for a geometric series. A sum for a geometric series is equal to a to the 1, 1 minus r to the n, all over 1 minus r. Okay, so for this series, let's just see what r was. So r was equal to a to the n plus 1 divided by a to the n, which is equal to 1/4 divided by 1/2, which will give me 1/2. Let's check it again, which is equal to 1/8 over 1/4, which is equal to 1/2. So yes, indeed, it is a geometric sequence. Perfect, and there's the ratio. So we know r, we know a1 is just equal to 1/2, and n is the tricky part, because n is going to go to infinity. As n goes to infinity. It's hard to put infinity in there. So let's just see what we're going to actually, let's just see what would actually happen. So for this ratio of 1/2, or r to the n, of 1/2 to the power of n, let's expand this out. So it's going to be 1 to the power of n all over 2 to the power of n. That's how you expand it with multiplication and division inside here. Every single term gets 1, or every single value gets 1. So it'd be 1 to the power of n and 2 to the power of n. And what does this really mean? This means 1 times 1 times 1 times 1 all the way for n times, which in this case we're going to infinity. And this one means 2 times 2 times 2 times 2 times 2 all the way to infinity. All the way to infinity. All the way to infinity. Okay, so 1 times 1 times 1 is going to equal to 1. And this one is going to approach infinity. And this value right here, let's just put some numbers into just to prove it to ourselves. If you put 1 over 100 in your calculator, you'll get 0.01. And if you put 1 over 100,000, you'll get 0.00001. And if you keep on going, you'll see this number gets smaller and smaller and smaller and smaller. If you put 1 over infinity, this is going to approach 0. And that's the point. So if you have an infinite geometric sequence, this ratio, if the ratio is in between -1 and +1, and we'll talk about that in 1 minute, but if this ratio is in between -1 and +1, this ratio goes to 0. And everything else stays the same. So let's do this example real quick. Let's finish this thing off. So sum would be equal to 1/2 times 1 over 1 minus 1/2. And that 1 minus 0.5 is equal to 0.5. 1 divided by answer is equal to that, times 1/2 is equal to 1. Okay, some rules for the ratios. So, a ratio, and let's see what the series would do. Infinite sum. So for ratios between -1, not equal to, and not equal to +1, so in between -1 and 1, these are convergent. It's a convergent series. You will get an answer like this. If you have a ratio that is greater than +1, or r is less than -1, this will diverge. Diverge. Okay, it will not go to a number. It's like having a ratio of 1, 2, 4, 8, 16, 32. Those are multiplying by 2. So the ratio here is equal to 2, and this sum will go to infinity. So it will diverge. Okay? If ratio is equal to plus 1, it will also diverge. That means it's having a number like 2, 2, 2, 2, 2. If you add up all those numbers, it's going to also diverge. And the last one is if you have r is equal to negative 1, it's also going to, it doesn't really make sense actually. Does not exist. Because a ratio of negative 1 would mean the number would look like this. 2, negative 2. 2, negative 2. 2, negative 2. So it doesn't, which one do you land on? You'll always flip back and forth. It'll be 0 or 2, or 0 or 2, or 0 or 2. So it doesn't really exist. So those are the things that you need to memorize. Well, the only thing you really need to memorize is that the ratio needs to be between negative 1 and positive 1, and you'll have a convergent series.